Two disks have moments of inertia I₁ and I₂ about their respective axes perpendicular to the plane and passing through the center. They are rotating with angular speeds ω₁ and ω₂ respectively and are brought into contact face to face with their axis of rotation coaxial. The loss in kinetic energy of the system in the process is given by. So first of all, initially there are two disks, and the final case they are brought into contact. So initial case we have conservation of angular momentum, and by that we can write I₁ ω₁ plus I₂ ω₂. I omega is the angular momentum formula, is equal to I₁ plus I₂ into common angular velocity after going into contact. Therefore we can write omega is equal to I₁ ω₁ plus I₂ ω₂ by I₁ plus I₂. Now let us take kinetic energy formula is half I omega square. So we have initial kinetic energy Ki is equal to half I₁ ω₁ square plus half I₂ ω₂ square, because they are separate. Now finally they become to contact, so we have half into I₁ plus I₂ into common angular velocity squared. Now we know omega, we've got an expression like this. Omega is equal to, we can substitute that, and also we can, since we have to find the loss of energy, we can use Ki minus Kf. We'll get it as half into, half is common to all terms, I₁ ω₁ square plus I₂ ω₂ square minus I₁ plus I₂ into omega square. Omega, we have this formula we got, I₁ ω₁ plus I₂ ω₂ by I₁ plus I₂ whole square. So we have here, we can do square, and here also we can do square. Therefore this I₁ plus I₂, and this I₁ plus I₂ squares get cancelled, and we'll get an expression half into I₁ ω₁ square plus I₂ ω₂ square minus I₁ ω₁ plus I₂ ω₂ whole square by I₁ plus I₂. Now we can do solving. After solving we'll get the answer. Loss is equal to half into I₁ I₂ by I₁ plus I₂ into ω₁ minus ω₂ whole square. This is our answer we'll get, and we can check from the options. The option C will be the correct one, 3.